Welcome to today's explainer. Imagine for a second you're driving a high-performance sports car, but there's a catch. You are only allowed to fix it after the engine completely explodes at 150 miles an hour. Sounds insane, right? Well, that is exactly the incredibly high-stakes world of reactive energy and oil and gas infrastructure. If you've ever wondered how top-tier energy firms manage massive, complex machinery without constant, catastrophic breakdowns, you are definitely in the right place. Today, we're going to explore how the industry is making a massive, necessary shift from reactive, emergency-style firefighting to a highly structured, data-driven model.
To really wrap our heads around why this matters, we have to start with a pretty blunt question. What actually happens when a pipeline system just goes offline? Or when a major compressor trips, or a pump completely fails? Look, in the energy sector, that impact isn't just a minor inconvenience. It's immediate. A single failure instantly chokes production output, compromises safety, and completely threatens the continuity of the entire supply chain. We're talking about a truly catastrophic domino effect here. The stakes literally could not be higher. Okay, let's dive into this. Our agenda today covers 1. The zero failure reality. 2. The reactive maintenance trap. 3. The digital maintenance revolution. 4. Centralizing with a CMMS. And finally, 5. Proactive operational intelligence. Let's kick things off with Section 1, the zero failure reality. You know, energy and oil and gas facilities are built to run 24 hours a day, 7 days a week. Disruption is simply not an option. Think about these high-value, capital-intensive assets running continuously under immense physical stress. When you're dealing with that kind of intense, unforgiving environment, even the absolute smallest deviations in pressure, vibration, or temperature can rapidly escalate into a full-blown failure. They just do not have the luxury of downtime. Because of this nonstop demand, maintenance in this sector takes on a completely different meaning. It actually becomes a crucial extension of process safety management. In this zero-failure reality, maintenance isn't just sending someone out with a wrench to fix a broken pipe. It acts as a real-time control for operational risk. It actively protects infrastructure that's meant to last for decades against aggressive degradation like corrosion, fatigue, and mechanical stress. Ultimately, it protects the environment, and most importantly, it protects lives. Moving right along to Section 2, the reactive maintenance trap, the cost of chaos. Just think about the absolute chaos of running a massive facility reactively. This is what it looks like out in the field. You've got highly inefficient spare parts coordination, meaning the exact critical component you need during an emergency is, you guessed it, completely out of stock. You have safety and inspection data fragmented across dozens of random spreadsheets, or worse, just living entirely in a senior technician's head, which is, great until Bob decides to retire and takes all that crucial institutional knowledge straight to a golf course in Florida. Teams spend their days essentially fighting unplanned downtime rather than preventing it, and all of this massively amplifies the risk to both safety and the environment.
Now, what's really interesting is the stark contrast between the problem and the solution. On one hand, we have that legacy trap we just talked about, fragmented data, emergency procurement, constant firefighting. It's exhausting just thinking about it, right? But on the flip side, we see the future, CMMS integration. In this new model, we get centralized traceability, advanced analytics that predict failures before they ever happen, and interventions that are meticulously planned and completely controlled. So what is this magic bridge between chaos and control? It's a CMMS, or a computerized maintenance management system. Basically, this is a centralized digital platform that takes all of that critical information, your maintenance history, spare parts inventory, real-time asset data, and links it all together into one cohesive picture. This single tool is exactly what empowers operators to shift from simply reacting to sudden breakdowns to actually predicting and preventing them. A real game changer. That brings us perfectly to Section 3, Digital Maintenance, the Connected Ecosystem. We are seeing the rise of a fully connected maintenance ecosystem right now, so let's quickly demystify some of these buzzwords. First up, we have IoT, or the Internet of Things. In this context, we're talking about connected sensors placed directly on rotating equipment, monitoring vibration and temperature in real time. Then, we have artificial intelligence and machine learning, analyzing that constant stream of data to spot microscopic failure patterns long before a human ever could.
We even have augmented reality, which provides field technicians with step-by-step visual guidance during complex repairs to virtually eliminate human error. And all of this connects directly to the facility's main production systems through seamless API integrations, tying the entire operation together into one unified business network.
All right, Section 4, Centralizing with CMMS, Organizing the Chaos. Let's see how this all builds together. When a comprehensive platform, like ManWinWin, for example, steps in to serve as the brain for this ecosystem, you actually see a complete shift in company culture. Step 1 is the old way, sudden, catastrophic equipment failure. Step 2 is the panicked, reactive fix. But when you finally centralize your data in a CMMS, you graduate to Step 3, condition-based prediction. You actually know a part is wearing down weeks before it physically breaks. Which brings us to the ultimate goal, Step 4, a highly planned, highly safe and reliable intervention executed perfectly during a scheduled shutdown window.
And the absolute key to achieving that elusive Step 4 is full lifecycle traceability. A centralized system logically links every single work order, every safety inspection, and every spare part directly to a specific asset, like a high-pressure turbine or a massive compressor. Getting to this incredibly detailed level of traceability secures vital regulatory compliance, it streamlines instrument calibration, and it guarantees absolute measurement accuracy across the entire facility. Which leads us to our final stop, Section 5, Proactive Intelligence, Real-World Outcomes. I really want you to absorb this quote from our source material. Maintenance is an operational enabler, not a support function. Let that sink in. This is a massive, fundamental reframing for the industry. When you use data to logically structure your maintenance engineering and operations, finally align around the exact same goals. You aren't just out there fixing broken machines anymore. You are directly driving the stability, the uptime, and the overall efficiency of the entire production chain. And we can see that incredible operational impact when we look at the big picture. When you make the leap from reactive to proactive, you completely eliminate that wild cost volatility and gain absolute cost control. But honestly, perhaps even more exciting today, these smarter, data-driven maintenance strategies drastically reduce energy losses and inefficient equipment operation. This is a massive win. It means you are replacing high emissions and resource waste with dramatic and extended asset lifespans and monumental sustainability improvements. We've seen how the highest performing energy facilities use tools like ManWinWin to completely tame the chaos of extreme operations. So as we wrap up this explainer, I want to leave you with a crucial question to chew on for your own operational mindset moving forward. Are you managing your maintenance, or is your maintenance managing you? Thank you so much for hanging out with me for this explainer. Keep learning, keep optimizing, and I'll see you next time.